Building a dashboard for your IoT endpoint. In this module, we're going to install a simple dashboard to display your data. This is a dashboard I wrote in AngularJS specifically for this course, and we're going to configure it and serve it up on our endpoint. In this module, we're going to download the dashboard from GitHub. We're going to install Node.js, examine some of the code, and then start serving up the web page. This dashboard is already built, and it would take a whole other course to go over everything in it, but I'll give you a good idea of how it works. You're free to modify it in any way you like. This dashboard could be a starting point for your amazing project. Now I'm SSH'd into my endpoint server, and the first thing we want to do is get our API running as a service. To do this, go into the folder where your api.py was written and type in the following. Type this in and then press enter. This will run your script and ignore hang-up signals so that it'll run in the background. Next, we want to make sure that Git is installed. You may have already installed it in one of the previous modules, but let's go ahead and run it just in case. Okay, now let's go ahead and create a directory for this. Okay, now I've typed in mkdir for make directory, /home/web/repos, 2 ampersands, and then cd/home/web/repos. What this will do is create a directory, and then we'll cd into it. And now we're in /home/web/repos. Now let's pull down the repository for this module. Type in git clone, and then the following address. And you can download this repo from my set of repositories that's specifically built for this course. Okay, now that we've got the repository downloaded, let's go take a look at it. Now here we want to type in cd hands-on Internet of Things. Quick tip, you can type capital H-A and then hit the tab key and it should auto-complete that. Then /dashboard/app. Now in here we're going to want to make a small edit to app.config.js. And we want to scroll down to the constants area. And the only thing you're going to want to change here is the API host. I have it set here to internetofthings.jeremymorgan.com port 5000. This is the endpoint that I've been working on throughout this entire course, but your endpoint will obviously be different. So this is where you would put in your URL and your port so that it will connect to your API server. And then save and exit. Now the next thing we're going to need to install is npm, which is the Node Package Manager. We do this by typing in curl https://npmjs.org/install-sh, and then we're going to port that into our shell. Now next, we need to install Node.js so that we can serve up the web page. This is my preferred method for serving up HTML and JavaScript. Type in the following command to get the node source, and then press enter. Now, as the instructions say, we want to install Node.js through apt-get. We do that by typing in sudo apt-get install Node.js. Okay, now that's done. We're going to install a program called serve that's going to serve up our pages. In order to do that, we'll type in sudo npm install/g serve. And what that means is it's going to install serve into our Node.js and it's going to install it globally. That's what the /g command is for. And now we have everything we need to serve up the page. But first, let's take a quick look at the code. AngularJS is a JavaScript library that uses a model view controller architecture. The first thing you'll notice is the view, which starts here in index.html. The UI view directive is dynamically generated here. The index file also loads all the CSS and JavaScript that we'll need for this application. As you can see, we're using a lot of libraries here, such as AngularJS, jQuery, Chart.js, and Moment.js. Most of the things we see comes from heroblock.view.html. This is a view, and in here we have a canvas set up for our main graph, and we have 3 chart objects down below. These are populated with data from AngularJS. Most of what you see on the page comes from heroblock.view.html. This is one of our views, and in here we have a canvas set up for our main graph. We have 3 chart objects down below that. These are populated with data from angular.js. Now control.tempGraphData, for instance, is an array that has labels and values that will populate our chart. Now this is home.controller.js. This is the main controller of the application. It sets up the services and retrieves data from them. The getFullDataset function uses the async HTTP service to grab the last 30 records from the database. It's a full retrieval of all the data in the record, which we'll assign to variables. As you can see, most of these variables are unmodified from the service. We have a temp start value that sets where our temperature is initially set, but other than that, most of these variables are exactly as they are from the service. We set up some options for the chart object and then create 3 charts. If everything goes well, it should render on the screen, and if not, we'll render an error to the console. If everything goes well, it should render on the screen. If not, we'll render an error to the console. In home.services.js, we'll retrieve the data and prepare it for the controller. Now in here, you can see the getFullDataset. That function makes a call to our API endpoint and sends the data back to the retrieved data variable. In topGraphLast30, we'll take that data and parse it. We iterate through the raw data and then convert the temperature from Celsius to Fahrenheit into the temp variable. We then parse it and round it to a 2-digit precision. Then we also push in the timestamp and use moment.js to format it. In this process, we add up the temperature from each iteration and then average it later to get an average temp over the last 30 minutes. Even though we don't use it, this can be a very important addition to your dashboard in the future. Then we take the humidity, temperature average, pressure, and sea level pressure and round those numbers down. We then attach the timestamp and return it back. Now in our dashboard, we make a call to the API, we send it back, and we format it with a service. Then the controller takes those values, applies them to the view, and it shows you the page you see here. This is just a high-level view of the dashboard. I hope you extend and add on to it. Okay, now we need to serve up this web page. We do that by navigating to the following folder. Now this is the one that I'm using in mine. Yours could be different. It's wherever we clone that repo to, and then you want to go into the dashboard folder. And now we'll just type in the word serve. And as you can see, it's now set up a server on port 3000. So let's take a look at it. Now we can take a look at our finished product. As you can see, we have a nice line graph of the last 30 minutes, and down below that, we have some neat Google gauges that are displaying info, as well as the actual numeric info. Now this is real data that's coming from my Raspberry Pi in my kitchen right now. Now there's a multitude of awesome things you can do with this dashboard if you choose. Feel free to modify it and play it around. If you come up with something cool, shoot me a Twitter or an email with a URL so I can check it out. In this module, we downloaded a dashboard from GitHub. We installed Node.js, we examined some of the code, and we started serving up the web page. This concludes our IoT dashboard module.